Today, I'm super excited to share our first product, LLM Skill Control Plane, which we're simply calling as Trinity. This is motivated by one of my favorite movies of all times, Matrix, where the characters were able to become experts in new skills in just a matter of seconds. When we spoke with 50 plus agent builders, we learned that making the agent better in every new domain, say math, coding, compliance, finance, requires retraining, reevaluating, and hoping nothing else breaks. Skills get better in one domain, but quietly regress in another. And teams end up maintaining a zoo of skill-specific model variants that all drift apart. Trinity fixes that. It lets you add expert capabilities without any regression and combine them into one agent that performs consistently across all the domains your workflows rely on. And the best part is that you can instantly see how the skills interact. You can vibe check the merged expertise in real time right in the interface before you ship anything. Let me show you how Vizops gives you granular controls in controlling how different domains influence your model's final response. Here, we have taken two Llama 3 8 billion parameter models. One that has been fine-tuned on code alpaca dataset, which makes it a domain expert in code generation. And the other one that has been fine-tuned on a MetaMath dataset that makes it an expert in verbal math reasoning. And on the right side, we have a simple chat interface that allows you to evaluate your model's response in real time and check for failure cases. For example, let's try this prompt where we're asking this model to generate a valid Python function to return the solution to a simple math problem. Here we have set the weights for the code model to be 1 and math to be 0.7. Now let's run this and see how the model behaves. And there we go. The model has generated a simple Python function that calculates all the different parameters and returns the hours per month. Now let's see how the response changes if I were to change the weights. For the next attempt, let's reduce the weight of the code one to be 0.7 and let's increase the weight on the math skills. And once we just quickly update the model, let's clear the chat and try again with the same prompt and see how change of the weights influences the model's output. In this case, the model has responded in a much more verbal logic that MetaMath dataset is all about. Here, it is still written a Python function, but it has gone into extensive verbal explanation of all the different steps, and also in the end returns the final answer, which is 96, unlike our previous version where it just wrote the Python code and that was the end of it.